I'm now going to work some examples of solving equations with variables on both sides. A great place to start is to draw a line right through the middle of the equal sign. This is a really good visual reminder to yourself that this is one side of the equation which is separate from this side of the equation. It's not really going to be as big of a deal for this particular problem, but as you move later into more complicated ones, it's really going to help you out a lot. The first goal for solving these equations is to get it so that we only have one variable in the entire thing. That means you need to eliminate either the 5c or the 8c. It doesn't really matter which one you undo. If you do it correctly, you should get the same answer. But I personally would get rid of the 5c because it's going to make the whole process a little bit shorter. 5c minus 5c is simply going to be 0. They're going to cancel each other out. A very common mistake is for people to think that they need to subtract 21 minus 5 and get 16. That is not the right thing to do. Hopefully you remember from when we were simplifying algebraic expressions that if you have a variable, you cannot do 21 minus something with a variable because they are not like terms. So that 21 has not been affected by that minus 5c. So you're simply going to bring it down. Hopefully you do recall also that when you solve an equation, whatever you do to one side of the equation, in this case, subtracting 5c, you have to do the same thing over here, or else your equation will not be balanced. 8c minus 5c is 3c. So we have now met our first goal of getting our equation so that we only have one variable. The next step is to isolate the variable. That means to get him by himself. This operation is 3 times c. In order to get rid of that 3, you've got to use inverse operations. The opposite of multiplying by 3 is to divide by 3. And those two 3's are going to end up canceling each other out so that all you have left is the c. Sometimes people think that there's nothing left over on that side of the equation, and that's not the case. You're doing c times 3 and then dividing by 3 so that those 3's basically cancel each other out, and all you have left is the c. Of course, because we're solving an equation, since we divided this side by 3, we have to divide that side by 3. 21 divided by 3 is 7. So c equals 7. And of course, the all-important step at the end is to go back and check your answer. In order to do this, you take the value that you got for c and put it back in the original equation. So 8 times 7 equals 5 times 7 plus 21. 8 times 7 is 56. 5 times 7 is 35. Remember, order of operations, you multiply first. 56, ooh, both sides match, so that means you did it right. Now it's time for you to hit the pause button on this video, try to solve this one on your own, and then restart when you're ready to check. Now that you're ready, we'll begin by getting rid of the variable that has a number along with it. As I told you in the previous example, you really don't have to start with that one. You could have taken the 6d off, but because the 11d has a number with it, it's going to be a shorter process for you to go ahead and get rid of that variable. So on this side of our equation, we had 10 plus 11d, then I subtracted 11d, so all I have left is a 10. Remember our golden rule of equations. If I subtracted 11d over here, I have to subtract 11d over here. 6d minus 11d is minus 5d. Now, I just have a plain old one-step equation. Now I'm multiplying d times negative 5. I want to undo that multiplication by using the inverse of multiplication, which is dividing by negative 5. That'll leave you with just plain d. Because I divided this side by negative 5, got to divide that side by negative 5. So 10 divided by negative 5 is negative 2. Of course, I need to go back and double check my answer. So I'm going to check it right over here. So instead of 11 times d, I'm going to do 11 times negative 2 plus 10 is equal to 6 times negative 2. This will be negative 22 plus 10 is equal to negative 12. Negative 22 plus 10 is negative 12. Since I got the same answer on both sides, I know that I am right. Now this problem looks just a little bit different because it's got a little bit more to it. You still solve it exactly the same way. First of all, I'm going to once again draw myself a little line down the middle of the equal sign to remind myself this is one half of the equation, that's the other half of the equation, and now I need to get rid of one of those variables. Because they both have a number with them on either side, it's not going to be any faster to get rid of one versus the other. This is just a personal preference, but I like to get rid of whatever one has the smallest coefficient. Remember, that means the smallest number in front of the variable. Just a personal choice. You don't have to do it that way. That's just how I like to do it. 2e minus 2e means that they're going to cancel each other out. So all you have left over here is a minus 12, which needs to come down. Because I subtracted 2e from this side of the equation, I have to subtract 2e from that side of the equation. 7e minus 2e is going to be 5e. And don't forget, that 8 hasn't gone anywhere. He's still there. Don't forget about him. Now if you look, you've just got a plain old two-step equation that you should know how to solve. Remember that we've got multiplication and addition over here with the variable. When you are solving an equation, you have to undo the operations in the opposite order you would normally do them. So because order of operations says we would normally do the multiplication first, we're going to undo adding 8 first. To get rid of adding 8, you simply subtract 8. Going to bring down this 5e because that 8 and that 8 have canceled each other out. Because I subtracted 8 from over here, I have to subtract 8 from over here. Negative 12 minus 8 is minus or negative 20. It is a super, super common mistake for people to make. So they think negative 12 minus 8 is negative 4. So they think I have negative 12, then I took away 8 of them, so now I have negative 4. That is not correct. You've got negative 12, then you made it even more negative by subtracting 8, so it's actually going to be negative 20. You met your first goal of getting the variable by itself, but now you've got to, you've met your first goal of getting only one variable, and you've undone that first operation, but now you've got to undo this multiplication, and to do that, you've got to divide. Divide by 5, that's going to leave you with just plain e. Because you divided this side by 5, you've got to divide that side by 5. Negative 20 divided by positive 5 is negative 4. So negative 4 is equal to e. Of course, you need to go back and check your answer using the original problem. I'm going to do that right up here in the corner. So 2 times negative 4 minus 12 equals 7 times negative 4 plus 8. 2 times negative 4 is negative 8 minus 12. 7 times 4 is negative 28 plus 8. Negative 8 minus 12 is negative 20. Negative 28 plus positive 8 is negative 20. Because I got the same answer on both sides of my equation, I know that I did it right. Now it's time for you to hit the pause button and try to solve a similar one just like it, and then restart the video to check yourself. Even though it doesn't matter whether I get rid of the 3n or the 5n, I personally just like to get rid of the one that has the smaller coefficient. So I am going to subtract 3n from this side of my equation. That's going to leave me with 14. Because I subtracted 3n from this side, I'm going to subtract 3n from this side. 5n minus 3n is 2n. Don't forget about that minus 6. So now I really have a two-step equation now. 14 is equal to 2n minus 6. I get rid of the subtraction first before I get rid of the multiplication. Minus 6 plus 6 is going to cancel each other out, so I'm just left with positive 2n. Because I added 6 to this side, I have to add 6 to that side. 14 plus 6 is 20. Now I've got to divide by 2. That's going to leave me with n. Because I divided this side by 2, got to divide that side by 2. 10 is going to be equal to n. Of course, I need to go back and, oops, sorry, not a very neat equal sign there. Now I need to go back and check my answer. So in order to do that, I'm just going to kind of make a little spot right over here. So I'm going to do 14 plus 3 times 10 equals 5 times 10 minus 6. This side of my equation, I've got 14 plus 30, because that's 3 times 10, equals 5 times 10, which is 50, minus 6. 14 plus 30 is 44. 50 minus 6 is 44 also. So I know that I did the problem correctly. Sometimes when you're solving these kinds of equations, you've got a little bit of simplifying that you need to do before you can actually solve the problem. I'm going to start, once again, by putting the line right down the middle of my equal sign. This is when it starts to get a little bit more confusing, and that visual to remind you this is one side and this is the other can really help you out. You might notice that right here, you actually have two like terms that you can combine to make it a little bit more simple. 5x plus 2x is 7x. Now you haven't done anything to change the value of the right side of your equation. Sometimes people think that because you added something together over here, that you need to do something over here to the left side of the equation. So technically, you haven't added anything to this. All you did was make more simple what was already there. Now we're going to go ahead and solve the equation by subtracting the variable that is with the number. You're going to bring down the 9. Remember that I could have just as easily subtracted the 7x, but it's going to be easier to subtract the 4x because it's the one that has a number to go along with it. Because I subtracted 4 from this side, I have to subtract 4x from this side. 7x minus 4x is 3x. Now I just have a one-step equation. I'm multiplying x times 3, so I'm going to divide by 3. That's going to leave me with just x over here. 9 divided by 3 is 3. So x is equal to 3. You have not done anything new in this equation. The only difference between this one and the examples before is that you had some like terms to combine before you could start. You still need to go back and check your answer exactly the same as you did before. So we're going to put our value of 3 back in our original problem. So 4 times 3 plus 9 equals 5 times 3 plus 2 times 3. And let's make sure that it's going to balance. 4 times 3 is 12 plus 9, which equals 5 times 3, which is 15, plus 2 times 3 is 6. 12 plus 9 is 21. 15 plus 6 is 21. Because I put the 3 back into my original equation and both sides of the equation match, I know that I did it right. Now it's time for you to hit the pause button on the video and try this one on your own, then restart the video to check your answer. I'm going to start by solving this by putting my line straight through my equal sign. Here I've got some like terms that I can combine before I do anything else. 10d minus 3d is going to be 7d. I'm going to rewrite the rest of the equation. Now it doesn't matter which one I get rid of, but I'm going to go ahead and get rid of the variable that has the smaller coefficient. 3d minus 3d is going to be 0, so all I have left here is the 7. because I subtracted 3D from over here. Got to subtract 3D from over here. 70 minus 3D is 40. Now I've just got a two-step equation. I'm going to undo subtraction by adding. Because I added 13 over here, I'm going to have to add 13. Let me scoot this stuff out of the way here. Got to add 13 over here. Then I've still got 4D is equal to 20. I've got to undo that multiplication by dividing. D is equal to 5. Still have to go back and check my answer. So instead of 10D minus 3D minus 13 equals 3D plus 7, I got as my answer that D is equal to 5. So now I'm going to put it into my original problem and see if I was right. So 10 times 5 minus 3 times 5 minus 13 equals 3 times 5 plus 7. 10 times 5 is 50, minus 3 times 5 is 15, minus 13 equals 15 plus 7. 50 minus 15 is 35. 35 minus 13 is going to be 22. 15 plus 7 is also 22. Because both sides match, I know that I did it right. In this example, you have variables on both sides. But before you can do anything to get rid of either one of them, you're going to have to use the distributive property to get rid of these two different sets of parentheses. I'm still going to go ahead by beginning by putting a line through the middle of my equal sign. I'm going to use distributive property to get rid of these parentheses. So 3 times A is 3A. 3 times what is really a negative 3 is going to be minus 9. 2 times A is 2A. 2 times 4 is 8. Remember, one of the most common mistakes that people make when they're doing distributive property is they remember to take the outside number and multiply it times the first number inside, but they frequently forget to take the outside number and multiply it by the second number inside. So, for example, a lot of people might have done 2A plus 4. Then that accidentally messes up your entire problem. So make sure you're careful with stuff like that. Now you just got an equation with with a variable on each side. I'm going to get rid of the 2A simply because it has the smaller coefficient, which is going to leave me with an A. Subtracted 2A over here, so I have to subtract 2A over here. So it's going to be 3A minus 2A is just plain A. Don't forget about the minus 9. Now I just have a one-step equation. A minus 9 equals 8. So I'm going to undo that subtraction by adding. That's just going to leave me with an A over here. I added 9 over here. I'm going to add 9 over here. A is equal to 17. Now I need to go back and check my work and make sure I did it correctly. So I'm going to substitute 17 into the original problem for A. So instead of 3 times A minus 13, I'm going to do 3 times 17 minus 3 equals 2 times 17 plus 4. 17 minus 3 is 14. And then 17 plus 4 is 21. 3 times 4 is going to give you 42. 2 times 21 is 42. So I know I did it correctly. Now it's time for you to hit the pause button and try one on your own. This is 3. I'm going to change these variables from an S to an X, actually. So now, take a moment, hit the pause button, try to solve it, and see what you can do. I'm going to go ahead and solve it. First of all, I'm going to use distributive property. 3 times X is 3X. 3 times 22 is 66. 4 times x is 4x. 4 times 12 is 48. I'm going to get rid of the 3x because it has the smaller coefficient. Because I subtracted 3x from over here, got to subtract 3x from over here. Now I've just got myself a one-step equation. So I'm going to subtract this 48, which is going to leave me with just plain x. Subtracted 48 over here, so I'm going to subtract 48 over here. That is going to leave me with 18 is equal to x, but I need to go back and check my work. So I'm going to substitute 18 in. So instead of 3 times x plus 22 equals 4 times x plus 12, I'm going to put in 18 for all my values of x. 18 plus 22 is 40. 18 plus 12 is 30. 3 times 40 is 120. 4 times 30 is 120. I know I did it right. Just for the fun of it, let's try one more. Hit the pause button on the video. Take a moment, see if you can figure out how to solve this one. It's a little complicated. It's got variables on both sides. It's got like terms to combine. It's got distributive property. It's got the whole kit and caboodle. So give it a try and restart the video to see whether or not you got it right. I am going to go ahead and solve it. First of all, actually the first thing I want to do before I get started is draw my line down the middle. Then I've got some like terms to combine. 3h plus 2h is 5h plus 6. So I've got some distributive property I have to do over here. Remember that technically this is a negative 2 because it's got a subtraction sign in front of it. So minus 2 times h is minus 2h. Negative 2 times positive 3 will be minus 6. Now, just bring down your h. So it's 4h minus 2h minus 6. Then I've got another set of like terms I can combine. 4h minus 2h is 2h. Bring the rest of the equation down. Now I've got to get rid of one of those variables. I'm going to get rid of the one with the 2, which is going to leave me with a negative 6. I'm going to subtract 2h from over here, which is going to leave me with, let me scoot this stuff out of the way, which is going to leave me with 3h plus 6 is equal to negative 6. Still got a two-step equation to get rid of here, so I'm going to undo adding 6 by subtracting 6. That's going to leave me with 3h. Subtracted 6 over here, so I'm going to subtract 6 over here. Minus 6 is negative 12. Minus 6 is not 0. They're both negative, so it's going to make it even more negative. Divide by 3. H is equal to negative 4. Of course, I'm not quite finished because I need to go back and check my answer using my solution. So I'm going to take the original problem again. 3h plus 2h plus 6 equals 4h minus 2 times h plus 3. Now I'm going to put in negative 4. So 3 times negative 4 plus 2 times negative 4. 4 times negative 4. All I've done is gone in and put a negative 4 in the place of every h. So 3 times negative 4, 2 times negative 4, 4 times negative 4 is negative 16. Negative 4 plus 3 is negative 1. Negative 12 plus negative 8 is negative 20. Negative 20 plus 8 is negative 14. This will be negative 16 minus 2 times negative 1, which is negative 2. Change your minus to a plus, change the sign of next. Negative 14 equals negative 14. I know that I did it right. This concludes my examples. Hopefully they've helped you out. If you have any questions about the videos or comments about the videos, please don't hesitate to mention them to me when I see you in class on Monday. Thanks so much. Have a good one.